Hello everyone, very good morning. I hope you people are doing well. Today in the class we are going to practice thermodynamics and KTG questions. So let's start with questions, okay? So this is your very first question. I would suggest go through question first carefully, draw the diagram, highlight the points required, and then I will show you two questions from this passage. Generally from KTG and thermodynamics, maybe you will be getting passage sort of questions, match the column questions. So there is a lot of a scope of those sort of questions and also integer type. So these questions we will be, let's start. So everyone read the question. So I can reflect this. I mean, these are the questions. In question 18, partition is assumed to be rigidly fixed. And in that case, we have to calculate the final temperature. And in second case, partition is free to move without friction, no role of dissipative forces. And then we have to calculate total work done by the gases till the time they achieve equilibrium. Okay. So these are the two questions. This is a very good question in terms of if you want to understand all the concepts. Any lead? Anybody? Okay, let's come to the question and let's discuss it. Okay. So what is given? There is a container as shown in figure to have a movable piston. So this is your movable piston. We need to mark everything in this question very carefully. If we do that, then question is very easy. So let's write it. This is movable piston. The container and the piston are all made of perfectly insulating material, allowing no heat transfer between outside and inside the container. So if we consider this whole as a system, then delta Q will be 0. Okay? Now the container is divided into two compartments by a rigid partition made of a thermally conducting material. So this is conducting. I mean, heat can go from here to here and here to here. depending on what is the temperature difference. This can be from up to down or down to up. Okay. Now this is done. The lower compartment of container is filled with 2 moles of an ideal atomic gas. So here what you have kept, 2 mole of monoatomic gas at temperature 700 Kelvin. What about the upper compartment? What we are doing there? What we are keeping there? Again, 2 moles of an ideal diatomic gas. So here also 2 mole, but diatomic gas we are keeping at what temperature? We are keeping it at a temperature of 400 Kelvin. So these are the situation given, and always remember this piston is movable. Okay. Now let's talk about the question. So first question is what? Consider the partition of rigidly fixed. Partition to be rigidly fixed. So this was the partition. There was piston over here. We are not talking about this thing. We are talking about this partition. This is what? This is rigid, rigidly fixed. Okay. So it is fixed, meaning it won't move. What is the meaning of it won't move? Means volume this side and volume this side is not going to change. Because when it will move, then only volume of 2 compartments is going to change, right? So here volume will remain constant. We got this point. यानी कि work done will be 0. ठीक है? Volume constant, work done 0. When equilibrium is achieved, the final temperature of the gases will be what? So we have to talk about what will be the final temperature. ठीक है? How we will go around this question? What do you think? देखो वॉल्यूम कांस्टेंट दिख रहा है, मे बी हमारा सबसे पहला पहला इंस्टिंक्ट ये कह रहा हो कि यूज द आइडियल गैस इक्वेशन दैट इज पीवी इक्वल टू एनआरटी since volume is constant. Do one thing, P1 by T1 will be equal to P2 by T2. But we have no status of P1, P2. ठीक है? I mean, this thing we can use for any individual compartment. So for any individual compartment, we don't know pressure thing. We cannot calculate it also because we don't know volume thing, right? We only know the temperature. Then we cannot go around it. This option is cut. Now we can go around one more equation, that is your first law of thermodynamics, that says delta Q is equal to delta U plus what? Work done. Okay. So if you talk about any individual compartment, now let's talk about this one. So for this compartment also, volume is constant, W is going to be 0, and delta Q will be equal to delta U for any compartment, this or this, right? But let's talk about the delta Q. Just now I have said you, no heat is going outside the system. It means delta Q has to be 0 overall. So if this system is losing some heat, that heat will get gained by the second compartment. Okay? So whatever delta Q you are going to calculate for first compartment, magnitude wise, that will be same for the second compartment. Agree? Yes, it is going to be same. So आप यहाँ पे क्या लिखोगे? Delta Q1 plus delta Q2, it has to be 0. Because overall delta Q is what? 0. Delta Q is what? Delta Q1 plus delta Q. यहाँ पे मैंने delta Q1 इसको ले लो. ठीक है? It's like this. अब आप ध्यान से देखो, delta Q1 magnitude wise is equal to delta Q2. Now the question is how to write delta Q1. So delta Q1 is going to be either you know the heat capacity, you can write heat. Done hai? Either if you know, that is going to be equal to the change in internal energy. But how we can write now delta Q1 or delta Q2? Anyone suggest? You have to be careful in writing this. Q1 और Q2 के लिए मैं क्या लिखूं? अगेन मैंने एक चीज यहाँ पे गलत लिखा है. इफ यू कैन मार्क इट. एक चीज मैंने गलत लिखा है क्योंकि आई जस्ट फॉरगॉट पिस्टन इज मूविंग. सो मैंने बार बार उसको मार्क भी किया एंड अगेन आई डिड द मिस्टेक. सो व्हाट आई सेड इज कि पिस्टन वॉल्यूम क्या रहेगा? कांस्टेंट रहेगा. सो माय एक्सप्लेनेशन वेंट रॉन्ग यार. आई एम रियली सॉरी. पिस्टन क्या था तुम्हारा? मूवेबल था. दो दिस कंपार्टमेंट इज फिक्स्ड, लाइक दिस इज रिजिड. So this is rigid, this volume will remain constant. This will change, right? It is going to change. Why? Because this piston is movable. What is the meaning of this piston movable? Simple meaning is that it will always make sure that pressure inside the compartment is equal to pressure outside. Okay? Because if you look at the piston, outside pressure is P atmospheric, right? If pressure inside decreases or increases, what will happen? There will be tendency of the motion of this piston. And since this piston is free to move slowly, right? So it will move if pressure is going to get affected. And it is happening in this case, right? So this piston is not going to, this volume is not going to be constant here in this case. We cannot say this. अग्री एवरीबडी. सो यहाँ पे जो मैंने सबके लिए लिखा ना, सेकेंड कंपार्टमेंट के लिए सीन विल बी डिफरेंट, बट ओवरऑल एक काम करती हूँ, फिर से करती हूँ, ठीक है, क्योंकि तुम लोग कंफ्यूज ना हो जाओ भाई. यहाँ से ध्यान से देखते हैं. पिस्टन था ऐसे, ठीक है, दो कंपार्टमेंट था हमारे पास, एक था वॉल्यूम V1, दूसरा था वॉल्यूम V2. ठीक है, दिस वॉज फिक्स्ड. ठीक है, सो इफ इट इज फिक्स्ड व्हाट विल हैपन? V1 will be delta V1 will be 0. So here work done will be what? 0. And so here you can say delta Q will be equal to delta U. And this whole thing we are doing for compartment 1. Now let's talk about the compartment 2. In this compartment, what is happening? There is a movable piston. Suppose Karlo, heat transfer is happening like this. So if heat transfer is happening like this, energy of this, second compartment is getting energy to do work. Pressure will increase sort of, because if you're giving energy, randomness will increase. More molecule will hit the wall, pressure will increase. And if pressure is increasing, to balance that pressure to atmospheric pressure, this piston will move upward in that case. Okay? But here we don't have to take care of if it is moving upward or downward. Thing is, it will move such that inside pressure and outside pressure will remain balanced. Okay? So if here you say delta V2 is not equal to 0, delta Q you can write as delta U plus W. And one thing is important, pressure will be constant. In this process, pressure is what? Constant. क्योंकि यहाँ पे अगर आप लोग ध्यान से देखो, movable piston on the top, ठीक है, is it written? It will move slowly. It should be written. Okay, if it is not given, we are going to take it slowly only, because that is what we have studied in our curriculum. Okay, unless and until nothing is given, we will assume that this piston is moving slowly so that it is maintaining that pressure equilibrium every moment. Okay, now you talk about what? Total heat. So total heat, still it will be 0, because this is a this is an adiabatic wall, this is adiabatic, this is adiabatic, this is adiabatic. No heat transfer. So delta Q net 0 लिखोगे आप, और delta Q1 plus delta Q2 will be equal to 0. So overall delta Q1 has to be equal to delta Q2 magnitude wise. ठीक है, अब आप Q1 Q2 को लिख डालो. So Q1 Q2 हम लिख सकते हैं ना. फर्स्ट कंपार्टमेंट के लिए delta Q क्या है? delta U. And change in internal energy always we write as NCV delta T. This is how we write it. So this is your delta Q1. अब आप इसके वैल्यू को लिख दो. फर्स्ट कंपार्टमेंट वी आर टॉकिंग अबाउट NH2, इट वाज हैविंग मोनोएटॉमिक गैस, राइट? यस, मोनो. सो CV will be 3/2R. That is also given in the question. Delta T, since its temperature is 700, it's 400 Kelvin. Over time, heat will travel from here to here, high temperature to low temperature. तो 700 Kelvin से temperature घटने वाला है. So I will write here, let's say final temperature is 700. 700 minus T is equal to delta Q1. And since this is a diathermic wall, temperature will flow until the time temperature on the both side becomes same. So again, one more conclusion is there. Final temperature of both the side of compartment 1 and of compartment 2 is going to be equal, because they will be in thermal equilibrium, because they are separated by diathermic wall. Okay? So delta Q1 we calculated. Now we need to calculate delta Q2. Delta Q2 आप कैसे लिखोगे? देखो, हमने क्या बोला? प्रेशर कांस्टेंट रहेगा, एंड एट कांस्टेंट प्रेशर हीट गेटिंग रिलीज्ड और रिसीव्ड कैन बी रिटन एज व्हाट? NCP delta T, right? Is equal to delta Q2. This I can write, है ना, because pressure is remaining constant. That was the trick in the first question. CP होगा यहाँ पे. डन है. सो N2 है, CP वैल्यू विल बी 5/2R. if I'm not wrong, what is given here? In the second case, sorry, that is diatomic. So this is 7 by 2 R. Delta T, temperature is going to increase, T minus 400. This is equal to delta Q. अब आप इन दोनों को equate कर दो. So what you are going to equate? 2 into 3 by 2 R, 700 minus T को आप किससे equate करोगे? 2 into 7 by 2 R, T minus how much it was? 400, right? So this will get cancelled. R will get cancelled. And from here you are going to get 2100 minus T is equal to 7T minus 2800. Okay. So this will become how much? 6T is equal to
मैम -3T आएगा 21,100 -3T.
हाँ सही बोला आपने, थैंक यू. 7T plus 3T 10T होगा ना ये. एंड हाउ मच इज दिस? आप लोग कर लेना. So this is 4900. So T is how much? 490 Kelvin. ठीक है, थैंक यू. दिस इज ऑप्शन डी. अब हमें किस में जाना है? क्वेश्चन नंबर 19 में. ये भी आप इजिली कर सकते हो. सिंपली यू हैव टू सिंपली एनालाइज द सिचुएशन कि क्या हो रहा है. ठीक है. सो लेट्स टॉक अबाउट क्वेश्चन नंबर 19. नाउ कंसिडर द पार्टीशन टू बी फ्री टू मूव. So now V1 will also change, V2 will also change, work will get done both sides. Thing is changing, right? Then total work done by the gases till the time they achieve equilibrium. Equilibrium will be there, thermal equilibrium. ठीक है. So second case में क्या दिख रहा है? This will be like this. And what is happening? This is movable. This is movable. Again, here there is a piston. So pressure will be maintained this side, same as before. What we are asked? We are asked total work done. How you will calculate total work done? कैसे निकालोगे? देखो एक चीज तो क्लियर है कि temperature is changing both sides such that final temperature will remain same. And one equation again you can write here, that is delta Q1 plus delta Q2 will be equal to 0. This is going to be equal to 0. ठीक है. And how you will now write delta Q1 and delta Q2? Why we need to write it? First thing, because we need to calculate work done. अगर आप work done निकालो तो वर्क डन का फॉर्मूला आप दोनों ही केस में क्या करोगे? एक बार तुम लोग ट्राई कर सकते हो. आई वॉन्ट यू पीपल टू ट्राई इट, क्योंकि वी हैव ऑलरेडी डन द फर्स्ट थिंग. यू कैन अप्लाई दिस थिंग्स इन द सेकंड वन. डू इट एंड लेट मी नो. ठीक है. टेक सम 1-2 minutes, डू इट एंड देन वी विल मूव अहेड. एक चीज मुझे बस बता दो, ये दोनों कंपार्टमेंट्स में आई मीन वर्क इज गेटिंग डन, राइट? फाइनल टेम्परेचर विल बी सेम. सो व्हाट इज द स्टेटस ऑफ प्रेशर?
मैम प्रेशर उसने सेम ही बोला है, और ऊपर वाला पिस्टन अगर मूव कर रहा है तो वो एटमॉस्फेरिक प्रेशर ही होगा.
हम्म. यानी कि दोनों ही कंपार्टमेंट में जो भी मूवमेंट हो रहा है दैट विल हैपन एट ऑलमोस्ट कांस्टेंट प्रेशर, राइट? जैसे तुम लोगों ने एक चीज केमिस्ट्री में भी पढ़ा होगा, क्वाजी स्टैटिक प्रोसेस पढ़ा है ना. आई मीन यू टेक थिंग्स वेरी स्लोली. जैसे पिस्टन को हम इतना स्लोली मूव करते हैं कि एट एवरी टाइम वी फील लाइक pressure change is so small that it feels like outside pressure is equal to inside pressure. So almost in such cases we can assume that pressure is what constant. At constant pressure things are happening. ठीक है? So here what is the case happening? जैसे पहले पिस्टन को अगर आप ले लो, तुम्हें बस यही आइडेंटिफाई करना है, फर्स्ट पिस्टन क्या कर रहा है, स्लोली मूव कर रहा है, सो इट इज मूविंग स्लोली, ठीक है, एंड दिस इज ऑल्सो स्लोली मूविंग, आई गेस. What is given in the question? Okay, here nothing is given. Okay, nothing is getting talked about speed, so we will take it slowly, as I said before. Okay, so if this is the case, it means what? Why the piston is moving? सबसे पहले why पे जाओ. Why it is moving? Because there is pressure imbalance. So it is moving to make the pressure same. So every small interval of time, it is moving in by a very small amount, such that pressure it is maintaining same on the both sides. So time and again I'm stressing on this point because here also it is happening at a constant pressure, and here also it is happening at a constant pressure. ठीक है, दिस वी कैन से. सो नाउ इफ, क्योंकि देखो कांस्टेंट वॉल्यूम पे तो काम हो नहीं रहा, हीट का हमने दो ही फॉर्मूला पढ़ा है. एक हमने पढ़ा है कांस्टेंट प्रेशर पे हीट इतना देते हैं, एंड अनदर वन वी हैव स्टडीड कांस्टेंट वॉल्यूम पे हीट इतना देते हैं. ठीक है, सो डायरेक्टली इफ यू वांट फॉर्मूला टू गेट यूज्ड फॉर क्यू, आइदर इट इज सीपी और सीवी. Here CV is not the case because volume is changing. Here CP will be the case because there is a movable piston that will maintain pressure is same at every moment. ठीक है, सो लेट्स यूज दिस. डेल्टा Q1 को आप क्या लिखने वाले हो? डेल्टा Q1 को आप लिखोगे फर्स्ट कंपार्टमेंट के लिए एन, एन इज सेम ऑन बोथ कंपार्टमेंट, सो एन को एन में लिखती हूँ. सीपी का वैल्यू क्या हो जाएगा? 5/2R, बिकॉज इन फर्स्ट कंपार्टमेंट मोनोएटॉमिक गैस है. डेल्टा टी का वैल्यू आप क्या लिखोगे? दोनों में ही टेम्परेचर सेम होने वाला है, सो आई एम गोइंग टू कैलकुलेट टेम्परेचर फर्स्ट, देन वी कैन डू द वर्क डन. क्योंकि वर्क डन भी कांस्टेंट प्रेशर पे हो रहा है, सो वर्क डन का फॉर्मूला क्या होगा? पी डेल्टा वी. वी डोंट नो पी, बट पी डेल्टा वी कैन बी रिटन इन अनदर फॉर्म, अनदर वे ऑल्सो. हमेशा याद रखना पीवी इक्वल टू क्या होता है? एनआरटी. Do the small differentiation both sides. So P delta V plus V delta P can be written as NR delta T. So at constant pressure, this is zero, right? This is zero. So P delta V is equal to how much? NR delta T. So we can calculate work done by the compartment 1 and 2. So if we know final temperature here and if we know final temperature here, in both compartment final temperature will be same. Here initial was 700, here initial was 400. We can calculate work done in 1 by nr delta t. Delta t is your how much? 700 minus t plus nr delta t. Here it will be how much? T minus 400. You just need to do total work done we have to calculate. So simply we need to add W2 plus W1. That will give us W. So basically we require temperature, equilibrium temperature. And that we can easily calculate, right? Yes. हिमांशु, कुछ तो गड़बड़ किया तुमने, -100 आएगा. ठीक है, सो यहाँ पे आप डेल्टा टी लिखो. हियर यू विल राइट 700 माइनस टी, एंड इफ हियर यू डू द सेम थिंग, 7/2R टी माइनस 400. इफ आई गो ऑन टू इक्वेट दिस टू, अगर मैंने इक्वेट किया तो मैं क्या लिखूं बताओ? इक्वेट करूंगी, एन एन कैंसिल होगा, इन दोनों को इक्वेट कर दो, ये कैंसिल होगा, ये कैंसिल हो जाएगा, 2 विल गेट कैंसिल. 5 into 700 that is 3500 minus 5t. Look at the calculation. 7t minus this is 2800. So this is going to be 12t is equal to 28. This is some, how much? Okay, it will get added. So 35 plus 28 will be equal to 5300, right?
मैम 63.
Okay, 6300. So temperature क्या दिख रहा है?
5 to 5.
डायरेक्ट कट नहीं रहा क्या? कट रहा है? नहीं कट
कट
जाएगा. हाँ, सो दिस इज इक्वल टू 5, 2 and 5, right? So this is this. Put in the values now. If you put it here, n का value 2 रख दो, r रख दो. 700 minus 5 to 5 plus 2r 5 to 5 minus 400. How much we are going to get? 700 minus 500, 200. This is 175, right? So 2r 175 plus this is going to be 125. मेरा तो और ज्यादा ही आ रहा है. कितना आ रहा है ये? 0, 0, 3, 2r. दिस इज आई एम गेटिंग 600. मैंने कहीं साइन में डिफरेंस कर दिया क्योंकि दिस इज 175, दिस इज 125. आंसर के अकॉर्डिंग अगर
मैम ये
no,
फर्स्ट वाला नेगेटिव में आएगा.
कैसे?
मैम टेम्परेचर डिक्रीज हो रहा है ना.
फर्स्ट का टेम्परेचर, अच्छा साइन कन्वेंशन के अकॉर्डिंग मुझे लेना था, मैंने वैल्यूज लिखी. यस यस. सो अगर तुम फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में चले जाओगे ना, डेल्टा क्यू इज इक्वल टू लिखोगे डेल्टा यू प्लस वर्क डन. सो बेसिकली टेम्परेचर डिक्रीज हो रहा है, राइट? ओके, सो वर्क डन विल बी, एक सेकेंड, आई एम गेटिंग कंफ्यूज्ड. Delta U is how much? Temperature is increasing, sorry, decreasing. So delta U will be negative. And delta Q, that is again your equal to how much? NCP delta T. This delta T is positive. So this is positive, this is negative. Work done तो positive आ रहा है.
मैम अगर एनआर डेल्टा टी लिखेंगे तो टी फाइनल माइनस टी इनिशियल लिखेंगे ना.
Okay, okay, okay. Yeah, yeah. I just need to do the basic thing. Yes, sorry. Oh God. देखो यही सब मिस्टेक है ना जो नहीं होना चाहिए. फाइनल माइनस इनिशियल करना है ना मुझे. सो मैंने बेसिकली मैग्नीट्यूड लेकर कर दिया. सो डेल्टा टी फाइनल इज 5 to 5 minus 700. हियर फाइनल इज 5 to 5 minus 100. So this is your negative. This one is negative and this one is positive. So if you go on to do this, yes, you will get here 50. So you will get here minus 100 r, right? This will be the answer. Plus say 100. Yes, this is going to be the answer. ठीक है, चलो आगे बढ़ते हैं. आगे क्वेश्चंस इजी होगा. आई मीन नाउ यू डोंट नीड टू सॉल्व दिस मच और थिंक दिस मच. This question came in 2018. I am telling you KTG and thermodynamics का question don't leave please. You practice more क्योंकि इससे क्वेश्चन काफी इजी आते हैं. If you have basic understanding, you will be able to solve. This topic is always scoring. ठीक है, so do solve it. I will just give you 2 minutes for this question, not more than that, because you don't require that much time for this one. सभी को फॉर्मूला याद है ना? हीट करंट है, यानी कि रेट ऑफ फ्लो ऑफ हीट को हम क्या लिखते हैं? सिंपली टॉक इट, आई मीन इक्वेट इट लाइक और कंपेयर इट विथ करंट. ठीक है, करंट इज व्हाट? रेट ऑफ फ्लो ऑफ चार्ज. दिस इज रेट ऑफ फ्लो ऑफ हीट and that is equal to how much? Potential difference there. Here there is temperature difference divided by their resistance. Here also resistance. So resistance आप कैसे लिखते हो? Rho L by A. Rho is resistivity. And if you write it in terms of conductivity, it will become 1 by sigma. So here it is 1 by K L by A. Like this we write the heat current. Just think it like current. डन है। सो अगर आप ऐसे क्वेश्चंस को रजिस्टर्स की तरह सॉल्व करोगे ना, इट विल इजीली गेट डन, आई एम टेलिंग यू। सो ट्राई टू मेक इट इजी बाय bringing out proper comparison with current wala portion. Yes, I would appreciate answers. Please let me know. Yes, Sohil, that is correct. Very good. Everybody come forward, please. Himansu, yes, that's correct. Others, please come on. Come on, let me know. Okay, so how you're going to solve it? Simple है. यहाँ पे एक temperature sink है, that is of temperature T, maintained at temperature T1. This is maintained at temperature T2. And these two reservoirs are connected by two conductors. ठीक है? One has thermal conductivity K1, another has thermal conductivity K2. So in terms of resistors, we can say that it is connected by two resistors like this. One thing is common, these two are in series. So whatever heat current is coming from T1 side, same amount of heat current will flow through R1 and R2. So heat current has to be same through both, right? Let's say at the junction that is given in the question, I guess. What is the junction temperature given? It's given or not? K1 and
200.
K2 हमें compare करना है. Okay, let me go through the question first. T1 is maintained at 300 Kelvin. So let's write it 300 Kelvin. T2 is maintained at 100 Kelvin. This is this. Radius of bigger cylinder is twice that of a smaller. So if this is R, this is 2R. That is given. If the temperature at the junction of two cylinder in the steady state is 200 Kelvin, so here temperature is 200 Kelvin, then we are asked what? Then we are asked the ratio of K1 by K2. ठीक है. So simple है, heat current आप इसके through निकाल लो. How you will calculate? So heat current, let's say that is I. So I can be written as potential difference across R1. This is equal to how much? T1 minus 200. So T1 minus 200 divided by resistance. Resistance can be written as L by K1A. This I can write. Also, same heat current is passing through I2. So you can write again I2 with the help of this potential difference across R2. So potential difference across R2 is how much? 200 minus 100 divided by its resistance. That will be equal to how much? Rho, that is 1 by K2, L by area. Area of cross section यहाँ पे क्या होगा? Pi r square. This one I have taken equal to A, and here it will be how much? Pi into 2r का square, and that is basically equal to how much? 4 pi r square. So this is I mean how you will compare it. This is 4 times A, करेक्ट है. सो यहाँ आप एक काम करो, आप लिख डालो 4A. नाउ दिस टू A's I's आर इक्वल, राइट? सो आप इन दोनों को इक्वेट कर दो. इफ यू आर गोइंग टू इक्वेट इट, व्हाट थिंग्स यू आर गोइंग टू गेट? T1 minus 200. ओके, मैंने T1 क्यों लिखा? दिस वैल्यू इज ऑलरेडी गिवन, राइट? T1 इज हाउ मच? 300. सो 300 माइनस 200 को मैं क्या लिखूंगी? 100 लिखूंगी बाई 1 by K1 L by A, एंड दिस इज इक्वल टू हाउ मच? Sorry, this is equal to 100 by L by K2 4A, like this. 100 will get cancelled. You can clearly see here K1A is equal to 4 K2A. So what is the value of K1 by K2? That is equal to 4. So correct answer is your word 4. There cannot be any easy question. I mean there cannot be more easy question than this. है ना? इससे easy कुछ आ नहीं सकता. So we need to grab such question. I mean, you just have to pick it up instantly. You don't have to drop it. Now let's do this question. Okay. This is also from the basic concept of latent heat of fusion, conduction. These two concepts are mixed in this question. So read the question carefully. Again, I'm not going to give you more than 2 minutes because this is what this question requires. Take it and do it and let me know your answers. ठीक है, चलो. Always first try to draw the diagram. these questions I included to show you that questions can be easy sometimes from some portions, but always it is easy from some portions. At least one or two question you will be getting like this. Okay, so you have to attend paper very wisely. You don't have to go with the negative. Whatever you are doing should be 100% solid. So that will help you keep your marks in more positive side. Okay, it's important. Yes. Anyone? Just write the conduction heat transfer wala equation and use the latent heat of fusion and vaporization concept. Yes, Sohil. You are speaking something. I mean, you're not audible. Can anybody hear him? Am I audible? My network is good. Yes, no, Sohil. Yes, that's great. That is correct. Very good. I'm waiting for other answers. सभी लोग बताओ क्या आ रहा है. Chalo, let's do it now because we should not waste time more here. See what is question saying. Question is saying one portion of this rod is maintained at 0 degree temperature where there is ice and another side is maintained at 100 degree where there is water. Okay. So there is a point P which is maintained at 400 degrees centigrade. If it is maintained at 400, definitely heat from P will travel towards B and also heat from P will travel towards A. Okay, and equal amount of ice and water is getting vaporized in equal interval of time. Okay, what does it mean? Let's say here the heat that is coming out is equal to heat current is H1 and here heat current is H2. So H1 will be equal to how much? Let's say m amount of ice is melting here And so according to question, m amount of water will get vaporized from here. So H1 can be written as m into latent heat of fusion, because whatever heat it will receive, that it will utilize to melt the ice. Okay. And similarly, H2 can be written as what? MLB. ठीक है. Now H1 और H2 को और कैसे लिख सकते हैं? It can be written according to the formula of conduction. So H1 को आप क्या लिख सकते हो बताओ? H1 को आप लिख सकते हो potential difference, that is 400 minus 0 divided by rho L by L is how much? L is lambda x. So lambda x by A. And since area of cross section of the rod is same throughout, so let's say this is A, and this is equal to MLF. Similarly, 400 minus 100 by rho, what is this length? It is 10x minus lambda x. So basically, rho x 10 minus lambda divided by A is equal to MLB. Divide these two, simple. M will get cancelled and rho lam A got cancelled. Rho 400 by 300 in lambda, and this is equal to how much? LF. LF is how much? 80. Another is how much? 540. So this is this. This will get cut by 600 times, by 6 times. This is this with 2. And you will be getting here what? This is equal to how much? 8. Okay, 200, 100 को कट किया ना मैंने, 100 तो कट हो गया. So this is 8 is equal to 8 10 minus lambda is equal to, निकालना क्या है हमें? Find the value of lambda is equal to 9 lambda. I'm getting it wrong. I 400 minus 100, I wrote 300. 300. ओके, 8 से 54 नहीं कट कर सकते ना, गलत कट किया मैंने, सॉरी. सो यहाँ 10 minus lambda divided by this will get cancelled. 4 से ये 2 times, 2 से ये 27 times और ये 3 से 9 times. So now we will get what? 9 10 minus lambda is equal to lambda. 90 minus 9 lambda is equal to lambda. So 90 is equal to 10 lambda. Lambda is equal to 9. This is going to be your answer. Everyone agree with this? Everyone got it sorted? So simple tha, concept was not difficult. It was very simple, I would say. ठीक है. Now let's do this question. देखो, pressure inside spherical bubble को thermodynamics में डाला है, and it has happened thrice in JEE Advanced in last 10 years, thrice. So you should be solving these questions. Take your time, do it. I'm giving you 3-4 minutes. I mean, read the question, try using whatever you know, but try it. Sorry. एक्सेस प्रेशर तुम्हें पता है ना, बबल के अंदर कैसे फॉर्मूला होता है. आई मीन इफ देर इज अ बबल, देर इज एक्सेस प्रेशर इनसाइड इट. बबल मीन्स इट विल हैव two layers of surface exposed to the air. So basically, if P inside is Pi and P outside is Po, then Pi is greater than P naught. You must have studied in surface tension. And Pi minus P naught, that is the value of excess pressure inside, is equal to sorry, क्या लिख रही हूँ? Is equal to 4 into surface tension divided by radius. So 4s by r. In case of drop, it is 2s by r because there is only one single surface of thin liquid exposed to the air. Here, in the case of bubble, we get two surfaces. That is why 4, right? So this is the core formula you need to use. And then you need to pay attention on temperature is constant. And finally, we have to calculate excess pressure. Okay. Maybe I have got some answer. Yes, Himansu. That is correct. Very good. देखो क्वेश्चन क्या है. क्वेश्चन ये बोल रहा है कि इनिशियली अ ड्रॉप इज बबल इज इन अ चैम्बर. चैम्बर का प्रेशर इज पी नॉट इक्वल टू 10 to the power 5 पास्कल. And in that case, this drop, let's say, is having radius r1, temperature T naught, and excess pressure inside is given as delta P equal to 144 Pascal. Definitely, which is far, far less than 10 to the power 5 Pascal. And that is why there is assumption given delta P is far, far less than T naught. That is, excess pressure will be very much less than that of atmospheric pressure outside. In the second case, what we are doing, we are decreasing the chamber pressure 8 to 8 P naught by 27. Still, it is of the range of 10 to the power 5. And in this case, since we are decreasing outside pressure, this drop is getting smaller in size. So let's say its radius is R2. And this whole process is happening in such a way that temperature is remaining constant inside the bubble. So this is overall, the radius change of this bubble is an isothermal process. This is an isothermal process. Done it? We have to calculate excess pressure in this case. ठीक है? So तुम अगर पहले के लिए इक्वेशन लिखो for the first case, then P inside minus P outside. Is P inside given? No. So P outside will be equal to how much? 4s by R. R1. ठीक है? And if we write it for second case, then P inside will change because this is an isothermal process. Temperature constant, pressure and volume both changing. So Pi dash minus P naught dash दोनों ही change हुआ है. Outside change हुआ. That is why this got changed. And this is equal to 4s by R2. So somehow we need to calculate 4s by R2. That is equal to the additional pressure in second case. That is excess pressure in the second case. How we can go around it? Somehow we need to calculate R1 R2 का relation, है ना? If we know R1 R2 का relation, somehow we can what we can calculate this excess pressure. So how we can calculate R1 R2 का pressure? There is only one relation given to us. That is, this is an isothermal process. So Pi Vi will be equal to Pf Vf. Let's call this Pf. This should be equal, right? So Pi को आप क्या लिखोगे? P नॉट प्लस 4s by R1. So मैं इसी चीज को सॉल्व करती हूँ. Pi को क्या लिखने वाले हो? P नॉट प्लस 4s by R1 एंड V1 को क्या लिखोगे? 4/3 पाई R1 का क्यूब एंड दिस इज गोइंग टू बी इक्वल टू हाउ मच? Final pressure. Final pressure will be equal to how much? P naught 8 P naught by 27 plus 4s by R2. So here I will write 8 P naught by 27 plus 4s by R2 into what I should write. ठीक है, मुझे इसको थोड़ा इधर लिखना था, चलो मैं इधर ही लिखती हूँ. P naught plus 4s by R1 into 4/3 पाई R1 क्यूब. अब आप सॉल्व कर सकते हो. So you can do it now. 4s by R2 into क्या लिखोगे? 4/3 पाई R2 का क्यूब. ठीक है, whatever is getting cancelled, cancel it. Whatever is remaining, I mean keep it. क्या करना चाहिए मुझे बताओ. हिंट लो, यहां से देखो सॉल्व करना मुश्किल दिख रहा है ना? सो आप हिंट लो एक चीज का. डेल्टा पी इज फार फार लेस देन पी नॉट. दैट यू नो, राइट? What is delta P? This is delta P in first case. This is delta P in second case. Basically, delta P is equal to 4s by R1 और 4s by R2. So कहने का मतलब ये है कि 4s by R1 is far far less than P naught. 4s by R2 is also far far less than P naught और 8 P naught by 27. ठीक है. सो इफ दिस इज द केस, देन अगर कोई छोटा है हम उसको इग्नोर कर देते हैं, है ना? छोटे इंसान को ऐसे भी कोई नहीं पूछता, इग्नोर हो जाते वो लोग. यहाँ भी ये इग्नोर हो जाएगा. इसको आप इग्नोर कर दो, इसको इग्नोर कर दो. क्यों? क्योंकि दे आर एक्सेस प्रेशर एंड दे आर वेरी स्मॉल. सो हमने किया इन दोनों को इग्नोर. इसको कट कर दो. अगर आपने इसको इग्नोर किया तो ये क्या हो जाएगा? पी नॉट इंटू R1 का, सॉरी दिस इज क्यूब, R1 का क्यूब, दिस इज इक्वल टू 8 P नॉट बाई 27 R2 का क्यूब. अगर आप इसको अब सॉल्व करोगे, R1 R2 का रेशियो मिल जाएगा. R1 by R2 is equal to how much? 2/3. So R2 is how much? 3/2 R1. Sorry, R2 is, it should be greater now. It should be smaller, right? ये greater कैसे आ रहा है मेरा? R1 by R2.
मैम प्रेशर रिड्यूस हुआ है ना.
R2 is 3 R1 by R2. Oh God. लेकिन maybe in that case R1 is less than 1. ठीक है, maybe. So we should not doubt this calculation because everything looks correct. If R1 is less than 1, then R2 will be what? Less than R1? It feels like, yes. Anyway, let's go with the calculation. Now what we have to calculate? Excess pressure. So excess pressure तुम्हारा क्या है? Excess pressure is your this. How you will calculate it now? So in first case, it is already given 144 Pascal. ठीक है. So you already know Pi minus P naught, that is 4s by R1 is equal to 144 Pascal. So 4s by R1 is excess pressure in first case. Excess pressure in second case is 4s by R2. और इसको आप पुट करो. 4s by R2 को क्या रखोगे? 3/2 R1. This is equal to delta P. So this is basically 2/3 4s by R1 equal to delta P. So delta P is equal to how much? 2/3 into 144. Let's see if we are getting the answer or not. 3 4, 6, 6, no, 8. So 48 into 2, that is 96. Correct है. ठीक है. So this is how we can calculate or we can deal with excess pressure things. Done it? Whatever is given, always try to deal with those things carefully. Now do this. This question is again very easy, very easy. The easiest one that you can get. So we got this question in 2024. ठीक है? Let's do it. Yes. If you get the answer, then you can let me know. Yes. सोहेल different आ रहा है. You're doing it in absolute temperature because T is given in absolute temperature. T here is in Kelvin, C equal to KT. Do it carefully. Okay. हर्षिता, जीरो में प्रॉब्लम दिख रहा है. 2 more zeros will be there. सोहेल नहीं, तुम्हारे 3 जीरो तो ठीक है बट डिजिट ही गलत है. यस हर्षिता. Everyone do this, let me know. See, what is the question? Specific heat capacity of a substance is temperature dependent, is not constant. And that is given as C equal to KT, where T is in your Kelvin, because that is absolute temperature. If the heat required to raise the temperature of 1 kg of substance from this to this, the value is Nk, then N is what? Okay? N joule it should be. We have to calculate the value of N. So if you, sorry, Nk it can be because here K is the constant, right? So what is the heat given? हीट गिवन को आप क्या लिखते हो, m स्पेसिफिक हीट कैपेसिटी s डेल्टा t। सो हियर m लिखो, s कितना है तुम्हारा kt, kt लिखो, एंड स्मॉल टेम्परेचर डिफरेंस को dt वी कैन राइट, ठीक है। सो दिस इज द स्मॉल अमाउंट ऑफ हीट वी कैन गिव। What is the heat given to 1 kg of mass when you are raising its temperature from this to this? So this temperature means what? Here it is given that 0 Kelvin is equal to this much. If you add 273 both sides, so 273 Kelvin is equal to 0 degree centigrade. ठीक है। सो -73 डिग्री सेंटीग्रेड विल बी इक्वल टू व्हाट? आप 273 को प्लस कर दो -73 के साथ, so you will be getting 200 Kelvin. So this is 200 Kelvin. What is this? Add it with 273, you will get 300 Kelvin. So basically you have to range its temperature from 200 to 300 Kelvin. Integrate it to calculate the total heat. Temperature varying from where to where? From 200 to 300. Now simply solve it. M ka value is 1 kg. K is K. T square by 2. This is 200 से 300. अब आप इसको solve कर लो. You will be getting the answer. So 300 का square will be how much? It will be equal to 9 into 10 to the power 4 minus this will be equal to how much? 4 into 10 to the power 4. ठीक है, divided by 2. ठीक है, so this is 5. So k into 5 by 2 into 10 to the power 4, that can be written as how much? K into 25,000. ठीक है, so answer will be what? 25,000. Done. So question was बहुत ही simple. Do this question now. ठीक है, take your time, do it. Yes. Anyone with the answer? Okay, take some more time, do it. Let me. So let's discuss this question because this is from the mixture of 2 moles of an ideal monoatomic gas. ठीक है? सो मिक्सचर के क्वेश्चंस को कैसे करते हो, जैसे अगर अगर तुम्हारे पास सपोज कर लो देयर इज मिक्सचर ऑफ टू गैसेस मोनोएटॉमिक एंड डायटोमिक, ठीक है। सो हाउ वी डिफाइन सीवी ऑफ द मिक्सचर, how we define CP of the mixture, and hence how we define gamma of the mixture, ठीक है। So CV of the mixture हम कैसे लिखते हैं, that is written as if there is N1 mole of monoatomic gases then N1 CV1 plus if there is N2 mole of diatomic gas then N2 CV2, where CV2 is the CV of diatomic divided by N1 plus N2, and the same way we define CP mixture and all, ठीक है। Coming back to the question, there is a closed container having 2 moles of an ideal monoatomic and 1 mole of diatomic. So if you talk about monoatomic, then how many mole we are having? We are having 2 mole. ठीक है? So well, no, it's not correct. Calculation wise, maybe you have done mistake. So diatomic का कितना होगा? 1 mole होगा again. Done it? Now gas mixture does a work of 66 joule when heated at constant pressure. So we are heating at constant pressure. At constant pressure, work done हम क्या लिखते हैं बताओ? Work done is written as P delta V, and that can be written as how much? NR delta T. This one we can write, right? And here N will be equal to how much? N1 plus N2 R delta T. So this is the amount of work done, and this is equal to how much? 66 joule. What we have to calculate? Change in its internal energy. What will be the change in its internal energy? We always have one safe formula for delta U. No matter whatever is the process, is it isobaric, adiabatic, isochoric, whatever it is, delta U को हम हमेशा क्या लिखते हैं? NCV delta T. ठीक है? So if you go around here like this, N1 plus N2, CV क्या लिखोगे? मिक्सचर का, मिक्सचर का CV is going to be how much? N1 CV1 plus N2 CV2 divided by N1 plus N2. It is this NCV delta T. So this will get cancelled, and NCV delta T is equal to how much? N1, first is a monoatomic gas, so this is equal to 3 by 2 R plus N2. N1 का value लिख डालो 2, and N2 is how much? 1. CV2 is how much? 5 by 2 R delta T. ठीक है? This is this, right? इसको अगर आप solve करते हो, 2 will get cancelled. 3R plus 5 by 2 R. So this will become equal to how much? 11R by 2 delta T. So now we have two things. Work done. Work done is equal to N1 plus N2 R delta T. So this is equal to 3R delta T, right? And we have delta U. W we know already, delta U we need to calculate. So take the ratio of these two. You can get the answer now. Delta U by W is equal to how much? 11R by 2 delta T. So this is 11R by 2 delta T. And what is the value of W? In terms of this 3R delta T. So right here 3R delta T. This will get cancelled, and W is 66 joule. So this is 66. R will get cancelled into how much? Into this is going to be 11 by 2 into 3, right? So 2 से 3 times 33 times गया, और यहाँ से ये 11 times. So delta U is equal to how much? 121 joule. So this is how we can solve this question. Done it? So you can go around it like this. I hope it is clear. If not, you can let me know. Now let's do this question. This is one interesting question. So take your time, read it, then we will do it. Okay. We need to take care of both things, value of x and value of y. Okay, let me try to make you understand. So what is happening here? There is a soft plastic bottle. So soft meaning you can squeeze it. You can increase the pressure or decrease the pressure by pressing it or by unpressing it, right? And this is filled with a water of density this carries an inverted glass tube, and there is a glass tube here. So a bottle hai, there is a water inside, and then there is a glass tube. So what is happening with the tube? Tube has a mass of 5 gram and it is made of thick glass of density this. Initially bottle is sealed at an atmospheric pressure 10 to the power 5 Pascal. So initially whatever air region is inside the test tube, that also will have pressure how much? 10 to the power 5 Pascal. Okay? So that volume of the trapped air is 3.3 cc, and initially inside the test tube, the volume of air, here there is water and then here there is air, and volume of this air is how much? 3.3 cc. Bottle is squeezed from outside at constant pressure. Again, note that things are happening at constant, temperature. The pressure inside rises. Pressure बढ़ेगा तो volume घटेगा. So volume of the trapped air reduces. Done it? It is found that test tube begins to sink. Again, this point is notable. It starts to sink at a pressure P0 plus delta P without changing its orientation. At this pressure, volume is this, and pressure that changed is this much. About the value of delta V. So actually we can do it from the concept of sinking. So when something sink, अगर आप ध्यान से सोचो, whatever is, let's say its volume is V. This body has a volume V. So downward force is V rho G. Okay? And upward force is how inside Okay, I'm really sorry. I lost the network actually. So I was able to explain things, or it got disconnected well before. Let me know, please. Yes. Anybody? Okay. Sync नहीं हो पाया था. Okay, okay, okay. चलो ठीक है. So what is the question? I was just talking about how we can calculate the change in volume of trapped air. ठीक है. So let's talk about this one basically. एक second. So here I told you if there is a body, so this is the body, and if this is the body and you have dropped it in a liquid and it is sinking. Sinking का मतलब क्या होता है? आप लोग simple बोलते हो ना, gravitational force that will be equal to how much volume of the body into density of body, ठीक है, into g. And what will be the upthrust acting force of buoyancy that is equal to volume replaced volume of liquid replaced. So that is basically equal to the volume of body because body is completely inside the water, and this is rho L into G. So if it is sinking, both will be almost floating का condition अगर आप देखो floating के लिए आप क्या बोलोगे? V rho L G is equal to V rho S G. So sinking means it is just leaving the condition of floating. राइट. सो इट इज ऑलमोस्ट एट द कंडीशन ऑफ फ्लोटिंग. सो यहाँ से ये कैंसिल करोगे, यू विल गेट की डेंसिटी ऑफ सॉलिड इज गेटिंग इक्वल टू डेंसिटी ऑफ लिक्विड. देन ओनली इट विल सिंक, राइट? देन ओनली इट विल सिंक. Now here it is said that when its volume is getting decreased by some delta V times, then the body has tendency to sink. What does it mean? It has a simple meaning that this test tube, जो हमारा टेस्ट ट्यूब था, विच वॉज अर्लियर ऑक्यूपाइड विथ सर्टेन अमाउंट ऑफ एयर. सो ऐसा टेस्ट ट्यूब लो. अभी क्या हुआ, इसमें एयर की वॉल्यूम घट गया. वाटर इज मोर इनसाइड दिस. सो if I talk about I mean if it is sinking, अगर ये सिंक कर रहा है, इसका सिंपल मतलब क्या है? इसका सिंपल मतलब ये है कि density of this body is equal to density of liquid. ठीक है. सो दिस बॉडी इज मेड ऑफ व्हाट? यहाँ पे क्लैरिटी तुम्हें रखना है कि ये बॉडी किस चीज से बना हुआ है. सो दिस बॉडी इज बेसिकली मेड ऑफ ग्लास एंड इन सम ऑफ इट्स पोर्शन एयर इज ट्रैप. क्योंकि जिस रीजन में लिक्विड है उसका तो डेंसिटी ऑलरेडी रो एल है. वी आर नॉट कंसर्न्ड अबाउट दैट थिंग, राइट? सो वी आर कंसर्न्ड अबाउट व्हाट? वी आर कंसर्न्ड अबाउट ग्लास पोर्शन एंड एयर ट्रैप पोर्शन. सो ओवरऑल द total mass of how much? It has a total mass of 5 gram. ठीक है. And if its density is becoming equal to how much? I mean, what is given? Its density will be equal to how much? 1 gram per cc. ठीक है. Total mass of this is total mass of this body. This body is contained of what? I told you. This is contained of glass plus air. सो टोटल मास अगर इस बॉडी का आप लिखते हो तो मास ऑफ ग्लास प्लस मास ऑफ एयर डिवाइडेड बाय डेंसिटी, दैट इज I mean that should be equal to the density of liquid now, will give you the volume of body. That will give you what? Volume of body. ठीक है. सो दिस इज इक्वल टू हाउ मच? mg प्लस ma को आप क्या लिख सकते हो? मास ऑफ ग्लास कितना था? 5 ग्राम. So let's say this is 5 gram. Mass of air that we can neglect क्योंकि ग्लास के मास के कंपैरिजन में एयर का मास क्या होगा? बहुत ही स्लाइट होगा. So let's neglect it. Let's make it 0 divided by density of liquid which is equal to 1 gram per cc. So this is this equal to volume of body. So volume of body is equal to how much? That is equal to 5 cc. Now this volume of body is, I mean, is combination of two volumes. One is volume of glass plus volume of air. ठीक है? So now let's talk about it. This is equal to 5. Volume of glass can be written as mass of glass divided by density of glass. That was given as 2.5 something. Yes, 2.5 gram per cc. So 2.5 and plus volume of air is equal to 5. If you solve it, you will get it as 2. So volume of air now is equal to how much? 3 cc. Initially, volume of air was how much? 3.3 cc. And finally, we are getting it as equal to how much? 3 cc. So what is the change in the volume that we are getting? That is equal to your 0.3, right? So how we calculated it? It is very simple. Uh, it is in the state of sinking, means the density of this body will be equal to density of liquid. Body meaning glass plus air. ठीक है? So density of glass plus air is equal to density of liquid. Now, if that is equal to liquid, then we can calculate the volume of this body. ठीक है? So mass of this body, I wrote it like this. This can be equated to 5 because that can be taken as 0. Volume of density of body has become 1. So volume of body 5 cc. Again, this is part of two volumes, one glass, another air. From here, we are getting air volume finally, that is 3 cc. ठीक है? And finally, you can also calculate change in pressure. How? Because temperature is remaining constant. अगर आप बात करो, हमने इसके अंदर का फाइनल एयर का वॉल्यूम हमें पता है, दैट इज इक्वल टू हाउ मच? 3 cc. Initial volume was how much? This was your 3.3 cc. Initial pressure is also given, that is equal to P naught. So PV is equal to constant because at constant temperature these things are happening. So P1 V1 equal to what? P2 V2. Final pressure you can calculate. P1 is how much? P naught. V1 is how much? 3.3. P2 is how much? This is 3. And this is volume, sorry, P2 we don't know, that is 3. P2 is equal to I don't know. ठीक है? So P2 को आप निकाल सकते हो, कितना आएगा? 1.1 into P naught. 1.1 into 10 to the power 5. So हमें आंसर क्या करना था? डेल्टा P is y into 10 to the power 3 Pascal. So आप एक काम करो, डेल्टा P निकालो. P2 is this, right? So P2 minus P1 अगर आप करोगे तो क्या लिखोगे? P2 is how much? 11 into 10 to the power 4 minus 10 to the power 5. So this is basically equal to, I mean 1.1 into 10 to the power 5 ही लिखो आप. 10 to the power 5 into 1.1 minus 1. So that will give us 0.1, right? So this is equal to how much? We are getting 10 or 100. क्या आ रहा है? 1 by 10 into 10 to the power 5. हमें तो आ रहा है 10 to the power 4. So this is delta P. So delta P is equal to how much? 10 to the power 4. And here it is y into 10 to the power 3. So y has to be equal to 10. So this is going to be your answer. ये क्या हो जाएगा? Answer हो जाएगा. ठीक है? Any doubt, anybody? Whatever question you have done, I mean, you should go through it once more in order to be more clear of the concept. इस क्वेश्चन के थ्रू एक बार और जरूर जाना to understand it completely. ठीक है? तो क्वेश्चंस को ना पढ़ने के बाद थोड़ा टाइम देना चाहिए to understand. This question you can easily do. यहाँ पे कुछ भी नहीं करना, simple integration करके you will be getting the answer. So this question is basically from your Boltzmann, Stephen's law, right? है ना? So you just take time to read it for 1 or 2 minutes. I will explain the question and then we can leave. Or whatever you say. I'm okay with all the options.
मैम
हाँ बोलो.
मैम तो क्वेश्चन भेजा था मैंने मैग्नेटिक फील्ड वाला, मैग्नेटिक प्रेशर.
अच्छा तुमने भेजा है?
हाँ
अच्छा वो
मैम.
तो नंबर ओके, मैंने देखा है, मैंने तुम्हें थम्स अप भी दिया है। आई विल बी सेंडिंग यू द सोल्यूशन, ठीक है।
ओके मैम।
हाँ, मैं तुम्हें सॉल्व कर, एक्चुअली टाइम मिला नहीं ना, आई वाज एंगेज्ड एक्चुअली, तो आई कुडंट डू इट, सो आई थॉट कि क्वेश्चन मांग लेती हूँ, देन आई विल डू इट, ठीक है। आई विल डू एंड सेंड यू द सोल्यूशन। ओके ओके, सो यू पीपल विल डू दिस क्वेश्चन। क्वेश्चन में देखो, यहाँ पे एक ही चीज से केयरफुल होना है, दैट इज देर इज a small object at the center of a large evacuated hollow spherical conductor. So it is kept at the center. There is one object, and this object is at temperature what, 200 Kelvin, and this evacuated chamber is maintained at temperature 0 Kelvin. What does it mean? Maintained कहने का मतलब this container is not going to participate in radiation. सो अगर तुम लोगों को स्टीफेंस लॉ याद हो, पावर गेटिंग जनरेटेड का फॉर्मूला लिखते हो, सिग्मा ई ए टेम्परेचर ऑफ बॉडी का 4 माइनस टेम्परेचर ऑफ एटमोस्फेयर का 4, ऐसा लिखते हैं ना। दिस केस वी राइट व्हेन एटमोस्फेयर इज आल्सो रेडिएटिंग, ठीक है, एंड इट्स टेम्परेचर इज आल्सो चेंजिंग, बट नो, in this case it's not radiating, so simply power getting radiated from this surface will be equal to, not this formula you have to use, sigma ea t ka power 4, where t is the any random temperature at any time t of this body. So question got more simplified with the statement that container is maintained at 0 Kelvin, ठीक है। at t equal to 0 temperature इतना है, the temperature of objects become this at t1 time and this at t2 time. Assume the object and the container to be an ideal black bodies, that is E will become 1. The heat capacity of object does not depend on temperature. Temperature पे depend नहीं कर रहा. Then the ratio T2 by T1 will be equal to what? ठीक है. So you already know one thing. Power, suppose कर लो at any time T, its temperature is T. How much heat it is generating per unit time. So if you write heat getting generated per unit time, you will write sigma EA T ka power 4. And this is rate of heat flow, right? So this is basically your dq by dt. And dq can be written equal to how much? जैसे तुमने जो न्यूटन्स लॉ ऑफ कूलिंग का डेरिवेशन किया है ना, दैट इज व्हाई आई से कि डेरिवेशन इंपॉर्टेंट होता है फ्रॉम द पॉइंट ऑफ व्यू ऑफ जेई एडवांस। वहां पे हमने क्या लिखा था, इसी हीट को हमने कंपेयर किया था, दिस इज डी क्यू, अमाउंट ऑफ हीट इट इज लूजिंग, सो दिस कैन बी रिटन एज एम एस डी टी, राइट, बाई डी टी, एंड दिस इज इक्वल टू सिग्मा ई ए टी का पावर 4। सो फ्रॉम हियर यू कैन इजिली सॉल्व इट। इसको आप क्या लिख सकते हो, डी टी टाइम को ऐसे लिख लो, दिस विल बिकम इक्वल टू एम एस बाई सिग्मा ई इज 1 हियर, and that will become how much, dt by t4, and time initially at t equal to t1 it is 100 kelvin, that is from the time 0 to t1 its temperature changed from, at t equal to 0 its temperature is 200, so it changed from 200 to 100. And similarly again you will write this equation for to another range dt equal to ms by sigma ea, and this time temperature is changing from what to what, from, I mean in T2 time it is changing from 200 to 50 Kelvin. So you have to calculate the value of T2 by T1. Simply you will calculate, put this as equation 1, put this as equation 2, take the ratio, sorry, this one as 2, take the ratio of these two equations, you will be getting the value of T2 by T1. Okay? So this is how you need to solve this question. So that was all for today's class actually. This was all I included, and I will request every two of you to do more questions from KTG and thermodynamics, because AG questions will be from this book. If you practice, you will be able to do it. ठीक है? Any doubt? Thank you, Harshita. Thank you, everybody. Shovel, I will be sending you a solution very soon. ठीक है? तो डोंट
ओके।
वरी। हाँ ठीक है ठीक है।